this talk as well. So, without further ado, I'm just going to go ahead and hide myself and kind of let you take over and let you run. Thank you.
Thank you, Shannon. And welcome everyone to Guts, Butts, and Not Going Nuts. What can I say? So yes, that is in fact the title of the talk, and we will make clear why that is the title of the talk. But really the foundation of this talk is how nutrition plays a role in improving mental performance. So this is a presentation about mental performance, the gut microbiome, and how nutrition plays a role as the intersecting piece between these different topics. So just very briefly, hello, Erika Engel, the co-founder and CEO of Excella. I have an undergrad degree from MIT, a PhD from Boston University School of Medicine. Back when first we met, I was 40, I am now 41. And I am still an entrepreneur, and I am still a biochemist, and I am still dedicating my life to studying the importance of the gut. Obviously something very, very passionate about and excited to be here to talk with you about. The topic is also personally relevant because I am frequently facing gut issues even now. I'm trying to figure out how to balance life and stress with having this issue and having to be on my my A game as much as possible. And from everything from standing up in front of thousands of people and giving talks to even just standing up in front of my team and doing my best to be a thoughtful and responsible leader. It's definitely very, very stressful and requires a lot of mental performance and being on that A game. So this is a very important topic to me. So today's talk is going to span kind of a whole variety of different areas. So we're going to talk about first, what do we mean by mental performance? We're going to define that. Then we're going to spend a little bit of time talking about the gut microbiome. For those who have seen my talks before, we always talk about that because we never know whether folks know about what it is and why it's important. We're going to talk about ways that gut health impacts mental performance. And then we're going to talk about some nutrition tips that can help you to potentially improve your gut microbiome, and in doing so, help to improve your mental performance. So what do we mean by mental performance? How do we define that? So we define that in, I'd say, 4 different ways. So 1, the ability to manage mood and emotions to effectively lead. 2, to think clearly while you're having important meetings. 3, the ability to maintain focus and the motivation to do important tasks. And then lastly, the ability to wake up, sleep, feeling rested and energized for the day. These things are very, very important. And I think really are the foundational building blocks for what helps us to be able to perform. So why am I here today? One of our favorite lines at Excella, at my company, is this line: don't let your life ambitions get derailed by biology. And we fully believe that there are things you can do to improve your performance, to make yourself feel better. And again, the topic here, of course, is drawing that connection between mental performance and gut health. They are very intimately related and influence each other. And guess what? There's things you can do to improve them, to improve your performance in general. So the focus today is how the gut is connected to mental performance related issues. This is a presentation co-starring our 2 leads, the brain and the gut, nicknamed the Brut. Let's first start to sort of understand this by talking about the gut microbiome. What is the gut microbiome? Why is it important? And how ultimately do we actually, do we have control over it? What do we control? So The digestive system includes the mouth, the esophagus, the stomach, the small intestine, and the large intestine. So from entry to exit, everything that sort of goes in one end and comes out the other. The gut microbiome is the all of the critters that live inside of it. So the trillions of bacteria, fungi, viruses, cells, all of these microorganisms that comprise that live in this system. What's important to understand about the microbiome is that we talk about good bacteria and bad bacteria. It's not really that simple. What you really want to have is a diverse set of different types of bacteria. All of these bacteria play a very important role, and they're in sort of a Darwinian competition with each other, meaning that they're vying for life and they're sort of trying to push the other guy out, right? And so they're competing for that space, and they all play an important role. So, when we talk about, well, you have too many of these bad bacteria, why is that a problem? Well, because they can potentially push out some of the other bacteria that you need. And so again, diversity is key. Having this competitive ecosystem, this Darwinian competition in the gut allows for all these different little critters to exist in your system and to be able to do their job. Lots of research has shown that there is just a correlation between good gut health and long-term health in general. So if you have a healthy microbiome, you typically have more energy, you get sick less, you have better mental clarity and better emotional well-being, versus a lot of research, again, showing that if you have an unhealthy microbiome, you are more susceptible to autoimmune issues, mental health issues like anxiety and depression, potentially even diabetes, and now recently data showing that even diseases like Alzheimer's could potentially be tied to an unhealthy microbiome. For the sake of this conversation today, we're going to be focusing on the two circled topics in the bottom left. So we're going to talk about mental clarity and good emotional well-being. So you might say, well, like, how much control do I really have over any of this? And the reality is you actually do. You have the ability by feeding, right, all the food that goes into the body, but not feeding certain bacterial species in the gut. So you are able to shift that ecosystem very effectively. So let's say you have a diverse, healthy microbiome with lots of different critters inside, some that digest veggies and meats and oils and breads. And now let's say you've decided, I really am just going to eat hot dogs, pizza, and ice cream. Sometimes it's very appealing to think about that. And so what does that mean? Well, that means that the bacteria that take in and eat those different meats and fats and oils, you're feeding them, you're giving them a competitive advantage over all of the other ones. Again, like I remember I had mentioned, like you're shoving them out essentially. So you can now skew the microbiome, skew the ratios of those types of bacteria so that now you have more of those types present. And those types are typically the more negative or invasive bacteria. So why is this important? Well, it's important because your bacteria take in the nutrients that you get from your diet and they break them down and they spit them out into your systemic circulation. We're going to talk more about how this works. And those building blocks are used by the body to do all kinds of cool things, from building your hair and nails, to building your immune system, to allowing you to sleep, to allowing you to not feel, cruddy and crappy every day. I mean, those building blocks are key. So if you imagine on the right-hand side here, we have someone who has a non-diverse microbiome, not very many types of species, and they're trying desperately to, eat lots of foods and do the right thing, but the bacteria aren't there to be able to break down those foods. They're still trying to create those building blocks that the body needs to stay healthy, but really they aren't really able to because there's not enough of the right bacteria to do that. Versus on the left-hand side, you have a healthier, more diverse microbiome, taking in those different foods, breaking them down into these molecules, which are then being spat out into your circulation and being used as building blocks to build your system's health. So again, key to have diversity in your gut. So example, what do I mean by this? What do I mean by bacteria take things in and break them down? So Tryptophan is a really good example of a molecule. It's an amino acid, a building block of protein. It's found in lots of different types of foods. Typically, when you hear about it, you hear about it in turkey, but frankly, it's found in all kinds of other types of foods, from fish, eggs, chia seeds, spinach, different nuts, tofu. So your body, you ingest these foods, your body takes in that tryptophan in your gut microbiome is converted into other molecules, things like, for example, serotonin, which is important for happiness, and many other things. We're going to spend a lot of time on serotonin later in this talk. And also melatonin, that molecule that is important to help you stay asleep and fall asleep and stay asleep, which again, really important, obviously, that you have high quality sleep. So we come back to this again, just to drive this point home. You take in your foods, but if your microbiome isn't diverse enough to be able to break down all the different, foods that you're eating and spit out molecules like serotonin or melatonin, you're going to have a problem. So again, the damaged gut, not enough diversity on the left-hand side, healthy gut that has more diversity, able to properly break down and spit out these nutrients for you to use. So now let's talk a little bit about the brain. We could have spent probably a whole year learning about the brain. Specifically, we're going to talk about how the gut and the brain are connected. And again, it's a complicated pathway or series of pathways. We're trying to simplify just to drive a couple of important points home. So this is not the only thing that happens, but wanted to really drive the key points home. All right, so what is this? So this is a schematic drawing. Here we have essentially these cells in the middle, these red and blue things in the center of the screen. Imagine you have an intestine, right? And you've put it on its side and you've sort of cut it down the middle, and you're looking at it from the side. So each one of these gut lining cells, they're called the intestinal epithelium. The intestinal lining actually is only one cell thick, so it's very thin. That's why it's so easy to damage. You have different types of cells. We'll talk about what they are. So the red cells are your traditional intestinal lining cells. The blue cells are a very specific type of cell called the enterochromaffin cell. They actually make and produce serotonin. They're very important in the brain-gut communication pathway, which we'll talk about. Each one of these cells have these like finger-like projections that are called microvilli. Again, imagine your intestine. What we didn't show is the other half of it. So it would look sort of like this. And these finger-like projections are facing inward in your intestine. And the reason why they exist is to increase the surface area that is there for, once your nutrients are being broken down and absorbed, you want as much surface area as you can to absorb them as that food comes through your small intestine. So things are broken down. In each microvillus, there's a little blood vessel that takes those nutrients. That blood vessel joins up with your systemic circulation and then shuttles those molecules all around the body so that they can be used, like we mentioned before, for other purposes. Protecting those microvilli is a mucosal barrier. So it's a very thin layer of mucus that prevents damage. And it is in that mucosal barrier that your gut microbiome lives. So the bacteria are sort of suspended there in that gelatinous material, and that's where they exist. Now, this is where we start getting a little bit more artsy. There is a nerve that connects the cells of your intestinal lining, so specifically your enterochromaffin cells, but really a lot of the cells, to your brain, and that is called the vagus nerve. So signals that come from the intestine actually travel along the vagus nerve to the brain. On the other side, from the brain to the gut, you have your autonomic nervous system, so other nerves that send messages that way. So again, you have messages coming up to the brain from the gut on the vagus nerve, and you have messages going down from the brain to the gut through your autonomic nervous system. All right, so let's talk about how this all happens. So let's say you've eaten a taco, my favorite food, for lunch, and you're breaking this down. And so the bacteria of the microbiome are taking your fats, your lipids, your carbs, your proteins, and they're breaking them down into those building blocks. So things like tryptophan, tyrosine, another amino acid, or other short chain fatty acids. So these are other, very small structures of things that actually play important signaling roles in the body. And we're going to come back to them even later. So you're going to hear these terms a couple of times. Your tryptophan metabolites, or other molecules associated with tryptophan and these short chain fatty acids, actually, and you'll see this in more detail later, bind to different receptors in the enterochromaffin cell, signaling the cell to release serotonin. And that serotonin actually is a communicational factor. So it activates the vagus nerve and tells the brain, oh, there's things I need to do here. So it's important for appetite regulation. It's important for memory, and it's important for mood regulation. So again, you think, well, this is all happening in the brain, but it's not. It actually started, the genesis for that all started with what foods you were eating, and what bacteria were breaking down, and what was binding to your enterochromaffin cells, sending that signal to the brain. Now, also, what can happen is the brain then can communicate with your gut to release serotonin into your peripheral circulation. So the brain sends a signal back to the gut microbiome saying, you know what, we need some serotonin here. So you need to release serotonin into the systemic circulation. So again, it's really interesting how the serotonin is created. It is a signaling molecule. It goes in, it triggers the brain to go and do all these different things. And then the brain says, okay, yep, we need to release more of this serotonin. And it communicates back, making those cells now release serotonin into your systemic circulation. What role does, stress play in all of this? And again, this is where you might say, well, people talk about stress, they make a big deal out of it. Is it actually relevant? The answer is yes. So stress actually triggers your adrenal gland to make a molecule called cortisol. You've probably heard of it. Cortisol does a variety of things that are typically negative physiologically. It can prevent proper digestion. It lowers your immune response. It can cause issues with memory, burnout, depression. Why? Because typically, if your levels of cortisol are high, you're in a state of something called fight or flight, right? So your body has identified that, you're being chased by a dinosaur, and everything else doesn't matter because you need to get away from the dinosaur. So your immune system isn't working well. Your digestion isn't working well. Clearly, you're probably going to forget everything because there's a dinosaur chasing you. You're tired, you're stressed, all of this. So again, stress affects all of these things. And ultimately that goes, back to the microbiome and tells the microbiome, okay, we're shutting down. We're not doing anything. We're just going to be dysfunctional until this body gets out of fight or flight mode and can be in rest and digest mode. So what are the mental performance topics that we are going to focus on today? So we've picked 4, and we've kind of named them something a little bit more intriguing. So there's guts, butts, and not going nuts, as the title of the talk suggests. There's no more bumbling blather, stand and deliver, and zzz, get your Z's, the quality kind. All right, so we'll start with guts, butts, and not going nuts. So this is going to be primarily about mood regulation. We'll come back to one of the primary molecules that we're going to be talking about today. This is about serotonin. So what is serotonin? Why is it important? Well, it's known as the happiness molecule. So it is a hormone that stabilizes our mood. It provides us with feelings of well-being and ultimately happiness. But it has other really, really important functions as well. It can act as a neurotransmitter that helps, as we mentioned before, with communication via the enteric nervous system to help us feel happier. And again, on the left-hand side there, you see this bidirectional communication between the brain and the gut that we talked about before. Now, again, not necessarily related to guts, butts, and not going nuts, but I think it's just interesting. Serotonin is responsible for blood clotting. Very important. It's responsible for our bowel movements. I'm going to talk about how that happens. And ultimately, it's a precursor to the molecule melatonin, which is, like we mentioned before, key for falling asleep and staying asleep. And amazingly enough, a huge percentage of serotonin is actually produced in the gut, more than 90%. So how is it made? And ultimately, what does it do? So we're going to zoom in even more on this from that previous chart that you saw. So here we are again with our cross-sectional view of the small intestine. We have our intestinal lining cells, our intestinal epithelium, remember, one cell thick. The microvilli, those finger-like projections that are important because they are the ones that actually take in the nutrients as they're being absorbed. You've got your blood vessels in each of those microvilli, taking those nutrients and shuttling them to your systemic circulation, taking them to the rest of the body. You have your mucosal barrier, that sort of jelly matrix in which the gut microbiome lives. Interestingly enough, what is between the intestinal lining and your systemic circulation is an area called the lamina propria. This is where 80% of your immune system actually lies in wait. And it's one of the things, though it's not the topic of this talk, when your intestinal lining is damaged, when the cells start to separate, if you damage them, where material can actually go, instead of through the little blood vessels in the microvilli, food and other particles start to travel in between the cells, and they go into the lamina propria, where your immune system gets confused and thinks there's some foreign invader, starts to attack them, and you end up with immune responses to different foods. This is how food sensitivities are formed. So when we talk about leaky gut, that condition, that is what happens when your intestinal cells start to separate and things that shouldn't be going in between them go in between them and ultimately activate the immune system. And over time, your immune system gets hypersensitized to those specific foods that it's seeing, and that's how you end up with food sensitivities and allergies. Digression, but kind of cool. So the enterochromaffin cell is a very specific type of cell, and this is the cell where our gut serotonin is actually made. And here's how that happens. So, okay, we can talk about this. So basically, we mentioned this before, you have connected to the cells, these neurons. Again, the neurons carry some messages up to the brain, then to some messages to your myenteric neurons, which are those that are responsible for helping you go to the bathroom. So again, when we talk about serotonin, typically messages go two directions. One to the kind of push it out side, and one to the brain side, and we'll walk you through it. All right, so here we go. Our taco is back. Our bacteria have broken down the food in that taco, for example, the meat or the beans, into tryptophan and amino acids. Some bacteria are breaking down the fiber that's found in that taco into short chain fatty acids. Now, why is that important? Well, because the tryptophan, so those amino acids, are absorbed into the enterochromaffin cells, and there's a specific enzyme, basically a molecule, that takes tryptophan and converts it into serotonin. But what's really interesting is that the short chain fatty acids are necessary to activate that enzyme. So when people say, you should eat a lot of fibrous foods, why is that important? Why should you care? Well, because if you don't have the breakdown products of those fibrous foods, which are the short chain fatty acids, then your TPH1, you don't have to remember or care what it is, but it's a molecule that helps tryptophan convert into serotonin. You don't have TPH1, then your tryptophan is not converting to serotonin. And as we already established, serotonin is pretty important. So again, you need the short chain fatty acids, you need fiber in your diet, and you need those building blocks, tryptophan, proteins, in order to take those molecules and convert them into serotonin. The serotonin is then released based on what we mentioned before in that communication with the brain and then back. And then they travel along the neurons, activating your gut motility, allowing you to go to the bathroom, or going and activating neurons in the brain to create neurotransmitters and other really important molecules that you need. So serotonin is it's just an important molecule plus a signaling molecule. All right, so serotonin, again, bacteria breaking it down from the perspective of brain functionality. So one thing to note is serotonin cannot cross the blood-brain barrier. So what is the blood-brain barrier? So your brain essentially has this kind of a fortress around it. So not all molecules are allowed to pass through and get into the brain. However, but tryptophan, for example, can. So when bacteria break down protein into molecules like tryptophan, those tryptophan molecules are absorbed through the microvilli, travel through those little capillaries, join up with your systemic circulation. They can be transported into the brain. So again, sometimes it depends. And then that tryptophan can be converted to serotonin in a separate pathway in the brain. So it's you don't want too much serotonin. There's this kind of a very fine balance. You want not too little and not too much. All right. So if the gut is damaged, less serotonin is secreted. That's obviously bad for gut motility, can contribute to constipation. It's bad for our mood, bad for our sleep, and most importantly, perhaps, bad for all the poor people around us who have to tolerate us when we're having a really bad day all the time. All right, second topic. We call it no more bumbling blather. What does it mean? Well, this one's about cognitive clarity. So why is it that we get brain fog? And it's actually quite different for women and men. So we're going to present both. A lot of it has to do with hormones, actually, and deficiencies. All right, so for women, and for those who have seen the perimenopause or menopause talk, you will recognize this. As women age and their estrogen levels decrease, typically, over the age of 35 or 40, the source of energy that the brain uses to fuel itself changes. So when we're younger, typically the brain uses glucose, so sugars, to fuel itself. As we get older and estrogen levels decrease, that switches to amino acids rather than sugars. So these are protein building blocks. So typically what we see is, for women over this age, they start feeling this way because they're just not getting enough protein in their diet. And I think that's really quite fascinating. I think I wasn't even aware, now being in my 40s, how important it is to make sure you get enough protein. So big takeaway, this shift has significant consequences, right? Because if your brain, which is, sucking up a lot of the protein that you're eating, those molecules can't be used for other things. We're going to show you the pathway again to remind you. But remember, tryptophan, the building block of protein, is converted into serotonin, which is converted into melatonin. So if you don't have enough tryptophan at the top, you don't have enough melatonin likely to sleep. So you're having issues with your sleep. You're not producing enough serotonin, which means you're feeling kind of down and crappy. And then, in the case of other types of proteins, like for example, tyrosine, another amino acid, and we'll talk more about this. It's a precursor to a molecule known as dopamine, which is important for feel-good hormones. So why is it that many women who are, in perimenopause or menopause have these problems? Well, often it's because they just don't have enough protein in their diet. Now, for men, it's a little bit different. Again, as they age or as, testosterone levels change. They typically decrease. And as a result, serotonin levels also decrease. So there's pathways that show this, but in general, as testosterone decreases, serotonin decreases. And as a result, various thyroid hormones are also affected. So again, not enough serotonin to help with mood, not enough melatonin for sleep. And more importantly, these thyroid hormones are very important for memory and remembering things. And so memory impairment can happen as a result of this. And actually, if you remember back to our chart from the very beginning with the brain and the gut and the nerves and all of this, you remember that serotonin, when it was released along the vagus nerve, it stimulated the brain to have better memory. So again, as serotonin levels decrease, thyroid hormones change, your memory is affected. Stand and deliver, right? Focus and motivation. These are things that we have to do. And performance isn't just about practice. Sometimes it's just about having the energy and the will to do it. Often it is. So we're going to pick tyrosine since we've mentioned this before. So tyrosine, a very important amino acid found in different types of foods, nuts, lentils, cheeses, again, fish, edamame, yogurts, seeds, I guess, pumpkin seeds too. I saw that on the list. So why is it that you might just not be able to do this? You can't stand and deliver, and you're mortified every single time. And so it could be a protein problem, right? So we've mentioned that if you're not getting enough protein in your diet and your tyrosine levels are too low, well, tyrosine is converted in the gut microbiome into dopamine, which is then converted into epinephrine or adrenaline. So again, if you're a woman and, in perimenopause or menopause and your brain is sucking up all your protein, you're not getting enough, that's going to lower your levels of tyrosine, which is going to lower your levels of dopamine, which is your feel-good hormone neurotransmitter, which is going to also then increase, issues with epinephrine, deficiencies. Low levels are associated with feelings of anxiousness, depression, lack of motivation. So again, not good if you're expected to be on your A game. It could also be a dysbiosis, meaning a gut imbalance. So let's say you're getting enough tyrosine, and yet your gut isn't actually able to take in and process those nutrients, right? So you have, again, remember from the beginning of the presentation, you have the wrong composition of microbes in the gut. They're not able to take in tyrosine-related foods and break them down. And so as a result, all that's just being wasted. It's not being absorbed. And tyrosine is not being converted into dopamine, not being converted into adrenaline. Well, so what does it mean? Well, it means that you've not got a lot of initiative, to do much. And then ultimately, when you're chased by that dinosaur, the situation isn't going to be in your favor. So lastly, let's talk about sleep. Let's talk about getting your Z's and the really good quality, uninterrupted kind. Sleep is so important. It's key for memory. It's key for functioning. I don't know whether I'm sure everyone here has had a night where they haven't slept well, and the next morning they just feel like they've been steamrolled by, a tractor trailer. You just feel terrible. And it's not just about taking the right sleep aids. Oftentimes it's about diet. So people ask this question, why can't I fall asleep or stay asleep? What's going on? So we come back to this. So it could be a protein problem. Remember that the precursor to melatonin is tryptophan. So if you're not getting enough tryptophan in your diet, that tryptophan is converted in the gut microbiome to 5-HTP, which is then converted to serotonin and melatonin. And again, remember, if you're a woman who is in perimenopause or menopause, your brain is sucking up all those proteins. So you're not getting that. And again, if you're a man who, is again, over 40, testosterone levels are declining, your serotonin levels are declining. If serotonin levels are declining, it means that your melatonin levels are declining too. It could also be a dysbiosis problem. So again, you're getting enough food in your diet, but your gut isn't able to take in and break down these building blocks. And as a result, not converting it efficiently, again, into serotonin, melatonin, different pathway, but very similar outcome. So again, in our somewhat limited time together, since we don't have hours, but hopefully a few examples to try to explain and show why the gut is so important to mood and self-regulation, cognitive clarity, focus and motivation, and sleep. Now, we have a tendency to do lots of things to mess up the gut microbiome. What do we do? Well, one, while wonderfully and excitingly tasty, sadly, a lot of these foods, processed foods, definitely damage the gut, confuse the microbiome. They're not used to, ingredients that have 17 different, acronyms and letters and, 3-methyl diethyl, all kinds of chemical formula names. They've never seen this stuff. So it actually damages them. Every time you take an antibiotic, you end up wiping out some of your microbiome. And again, I think antibiotics are very important, not to say they're not. And if you have an infection, they're life-saving. Unfortunately, they don't discriminate between good and bad bacteria. So often if you're on an antibiotic, and especially for a long period of time, you end up getting diarrhea, you end up wiping out some of your microbiome. And sometimes it doesn't rebuild correctly, which can be very bad. We've talked about stress and cortisol, increasing inflammation, suppressing the digestive process, suppressing the immune system, that damages the microbiome. And if this is done for lengthy periods of time, can also, be something that is very difficult to reverse. A product that we all know very, very well. Again, we were sort of designed to play in the dirt, and sometimes living in an aseptic environment, or here's a picture of, kids these days don't go outside. And we're not suggesting that they should be bathed in dirt, but exposure to different types of bacteria are important because it helps to build the gut microbiome. So again, some of our first world practices are kind of our own worst enemy. So what can you do to support your gut microbiome and your mental performance? So you kind of have two choices. We've highlighted one because we clearly think one is better than the other, but you have two choices. So one, you can guess, right? There are general practices for, don't eat Doritos every day, right? So things that are general, and that could help with some general guiding habits. But ultimately, the best way to figure this out is to measure what do you need, and then to actually take a targeted approach to do that which is right for you and your body, because you don't know, is it a food issue? Is it a gut issue? Is it a stress issue? Is it what is the issue? And in order to pinpoint that, you have to measure it. And ultimately, that's what Excella does. So what are some general good gut habits? Well, one, eat high quality protein at every meal. I hope we've convinced you that protein is really important. So to do many things, but why? Well, to support, for example, tryptophan and tyrosine levels. These two molecules are so important. So many other things flow from them, right? The bacteria need these precursors to build these other molecules that your body needs to stay healthy. So how can you do this? Well, if you have a choice, instead of eating crackers, try edamame, try different types of foods, right? So, ultimately Excella, one of the things that we really are excited about is that we can identify, do you have enough protein in your diet? Are you consuming enough? And then also, if it's not just that, is your gut able to effectively process and break down that protein, right? And so it's two things: is do I have the bacteria I need to properly do this? And am I eating enough of it to satisfy my body's needs? And remember, other sources of tryptophan, lots of choices. It's not just about turkey. That will help you to elevate your serotonin. It will help you to elevate your melatonin and get better sleep. Other sources of tyrosine will help you to elevate your dopamine, to have more initiative, to just feel better, right? And elevate your epinephrine or adrenaline. So number 2, include foods that are higher in omega-3 fatty acids. So omega-3 fatty acids help to support serotonin production. So if you have a choice here between, well, the burger might look pretty good to you, you know, by this time of day, looks pretty good to me. Swap it for some fish. So try Alaskan cod. Again, with our test, which we're really excited about, we can actually look and see what your levels of serotonin are. Are they at optimal or are they below optimal? And then again, based on, you know, your gut being dysbiotic or levels of serotonin not being where they should be and some of your inflammation markers being elevated, we paint a picture for where the problem actually starts. Is it nutritional? Is it gut-based? Or are you just overstressed? Make fermented foods part of your daily routine. Why? Okay, so remember we harped on the importance of having a diverse microbiome. You have to have lots of different critters in there to break down all the different types of foods that you see in this picture, right? And some bacteria like radishes, some prefer cucumbers, some prefer tomatoes, and they all have a very specific place. So you need to have enough of them and a variety of them to make sure that you're able to break down all these different types of foods. And eating fermented foods actually provides fuel for all the different bacteria to make them happy, to make them thrive. So again, why test? Testing helps you to find out, do I have enough of these different bacteria, or do I have an imbalance? Am I dysbiotic, or do I have enough variety to be able to break down all these different foods? How do you do it? Well, instead of eating Cocoa Puffs, and I know when I told my husband that, he cried because he likes Cocoa Puffs, but try something else. Try Greek yogurt with fruit and rolled oats, just something that's fermented that can help fuel those bacteria. And there's lots of choices here. Kimchi, kombucha, sauerkraut. This is, I believe, apple cider vinegar. I mean, there's many different things that you can consume to help with that problem. You know, so ultimately, again, this is one of our favorite, I think, mantras at Excella. Don't let your life ambitions get derailed by biology. These are things that you can learn about. They're things that you can control. And your nutrition and lifestyle choices play a very, very important role in your mental performance. So it's not just like, well, I don't know what to do. You know, there are things you can tangibly do, and you can level up your career by, you know, optimizing your gut microbiome. So, you know, obviously we are very proud of our product and what we offer, and have worked with all kinds of different folks to address their challenges, you know, whether they be athletic or mental or physical, or, you know, we're always up for the challenge, and the product works really well. So that brings us to the end of this part of the presentation. Happy to take questions. There's a coupon code here if you're interested in the product. Please, you know, are happy to answer questions about it as well for a 10% off coupon at excella.com. Thank you.
Yay. Thank you so much, Erika. That was awesome. We have a handful of questions, so I hope you're
right.
I'm gonna fire away.
Good.
There were actually kind of a lot around the same topic, so I think I'm just going to start with those.
Sure.
And that's about the gut lining itself. So in sort of like resetting the gut microbiome.
Yeah.
So basically kind of asking, like how long does it take to potentially reset if someone's, you know, been on a fast food, high sugar, high fat type of diet for a long time, or even just like a week from traveling, or like how sensitive is the gut lining to kind of being skewed in one way or another?
Yeah, no, that's a great question. So I would say it takes about 3 months to change things. You might start to feel things earlier a little bit, but from the testing perspective, we recommend testing every 90 days because it does take time. But if you think about it, you spend your lifetime destroying your microbiome. So 3 months isn't so bad.
It's not bad.
Right.
Not
to
bad.
make a real change.
Okay, cool. And then kind of following up with that one, like probiotics specifically, I get this question a lot. Supplemental probiotics, right? So if somebody's taking them, like what is the percentage of them, making it through? We always think like, oh, they don't even make it through the stomach acid. And so is it even beneficial? Like, capsulated probiotics versus, the liquid stuff and that sort of stuff. So
it's a great question. I mean, every product is different. So, but here's my take on it. So there's a few things to think about. So enteric capsules are it's a specific type of capsule that only dissolves when it gets into the intestine. So you don't destroy everything before it even gets to the place where you want it to be, which is really in the small intestine. A lot of this action happens in the small intestine. So the pictures we were showing, those villi, that's all in the small intestine. So there's that. Things are still going to die on their way. It's just what happens, but that's why you're taking billions of CFUs. So some of them may not survive, but some will. I think the bigger issue with probiotics is they're not all created alike. So, you should look at the species that are in the probiotic. Not all of the species have research that substantiates why they're important. So, and that's, you can look to some extent, you can look that up if you're curious, bifidobacterial lactis. Like if you Google that and what's the research that substantiates why you should take this? Has anybody actually tested this thing? Or is it just a supplement that someone was like, oh, it has a cool new name and I'm just going to put it in a capsule and sell it? Sadly, because supplements aren't regulated the same way. I mean, you guys know this, not all of them are created equal. So the other thing to consider is the variety of species. So you might go and buy something that has only one species in it. You might go and buy a product that has 20 different species in it. Why is it important to have diversity, again, and variety in the capsule? Well, again, think about it. Let's say you're going to flood your system with 50 billion units of one thing. What happens? You've now given like insane competitive advantage to that one thing that is now like basically out competing everything else that was in there. So if you do that, you actually could create a problem. So we always recommend you're looking for, a probiotic that has at least 12 to 15, maybe more different species. The more, the better. And again, when you look all those species up and you say, yeah, okay, this one's been researched and it helps with improving intestinal lining, or this one is good for gut motility, or this one's going to help me poop, or whatever your challenge is. Like you can figure that out because they're not all created equal. So enteric capsuling can help. Things are still gonna, not everything's going to make it through. That's okay. Variety, making sure you have a product that has at least 12 to 15 different species in it. And then, how long do you do it for? You probably have to, again, it's like a 90-day, I would go for at least a few months. You can't just do this for like 2 days and think that it's going to change anything. Right. So do it for a couple months and then see how you feel. That's the other thing. Everyone is slightly different. There's going to be some products that you take and will make you feel great. And there may be another product that doesn't. So it may take a little while to find the right one that's good for you. And then give it a week before you really give up on it. And if things are still kind of like, then you can switch. But I would say once you found something you like, you should take it for a couple of months and see what happens. And then, you might be able to train yourself in the body to do the right thing. You may have to take it kind of forever, too. I mean, it just depends, right? Because your genetics are what they are. But, you know, for those of
Everyone's
us,
different.
yeah, I mean, for those of us who are chronically constipated, so you take a pill like me, you take a pill and then now you're not. And so that kind of solves, you know, the issue, and couple that with eating better foods, and now you've solved your problem. And then you might be able to wean yourself off of that pill once things start to improve.
Mm-hmm. Are there any species that like show up in like over the counter, like probiotic supplements that are like, why did you even put that in there? Like, that's like, just avoid those species kind of thing?
It's a tough question. You know, basically I mean, we can pull up, and we have a probiotic, and it's got 17 different things in it, and each one has a reference. We can send, not to push the probiotic, but we can send you guys the reference list, and you can read about. I'm happy to share all of that with you. And if people are interested in just, you know, fascinated with it, feel free to take a look and use that as a point of reference.
Yeah. Okay. All right. Just looking at some of the other questions here. What are your thoughts on medications for ADHD and how they interact with, you know, the brain and gut, or any of that kind of stuff there?
Okay, so I'm going to start by saying I am not an expert on ADHD. What I do know, and it's interesting that this came up. So over the summer, last year, we were talking with the head coach of, he now retired, former head coach for one of the big major league baseball teams. And he, you know, has won multiple World Series. And, you know, he was saying how right now, you know, due to the limited number of drugs that people can take, right, because of doping, one of the things that's happening is that a lot of the players are taking medicine, which is like ADHD medicine, for focus, and that's because it's for ADHD, like they can take it. What is happening though is they're not sleeping well. Their gut microbiome is messed up. They don't feel good. So there's all kinds of sort of side effects that are happening, you know, as a result of taking the medication. And, you know, typically we've heard this from, you know, other members of the team that those side effects can happen. So, you know, I don't want to ever tell anybody don't take your medicine, because if your doctor prescribed it and thinks that it's the right thing for you, it's like, who am I to say that it is not? I just think if you're on it, or if you know someone who is, just ask questions about it, figure out if it's really necessary, you know, and like all medicine, it's not just medicine for ADHD. You know, the real question is this something that is, you know, is it a problem that can be solved through more natural ways of handling it? You know, medication, it always escalates. You have to take more, your body adjusts to it. Now you're putting in more. Eventually it doesn't work. I mean, it's just like, there's all of these ramifications for long-term use of anything. So, but again, you know, this is kind of a conversation topic with your doc about it, but I just ask questions about it.
Yeah, no, that's good. I mean, just like with anything, ask questions.
I think so.
Okay, so you mentioned, you talked a little bit about the shift from the brain's preferred fuel source from carbohydrates to protein with you know, perimenopause, menopause. What is that like? Let's say, you know, average, you know, in your younger years, your brain's, you know, consuming, I don't know, 150 grams of glucose a day. Like what kind of shift are we talking about? Like the percentage change, do you know? Or is it just kind of preferred protein? I mean,
you know, it's funny. I'm going to call on Sam. She might actually know the answer to this question. My partner in crime here. Sam, do you know, I know that protein levels, we often recommend it's higher than what people typically recommend.
It is higher. I don't know the percentage though, and we could ask our science team to weigh in on this. I don't know that percentage either.
Yeah.
Just curious if someone's, you know, consuming 40 to 50% of their diet from carbohydrates, you know, as what really recommended in younger years. And now, you know, I'm 40, 50. How much does that need to change? You know, from was consuming 30% protein, 40 50% carbs, like how does that kind of shift? I was just curious. That was
we can definitely we'll find out. We'll find out, you know, for you, and then you can relay that. I know that typically in our, you know, meal plans and recommendations, protein intake is 25% higher than what others will recommend. So we do believe in protein being a big player.
Okay, cool. Okay, so just keeping an eye on the time, maybe time for one or two more questions. Thoughts about washing dirt from root vegetables because of the microbiome in the soil? Like thoughts on washing vegetables in general?
Well, look, you should wash your vegetables because you don't want to be eating dirt because you never know what's in the dirt. I'm not suggesting that we eat dirt. I just think that I should have been, you know, I think that the point is that when you're like really, really aseptic about everything, then you're not exposed to anything, right? And so it's a fine line and balance. But I would say, look, you should always rinse the vegetables. Things like anthrax also live in dirt. So best not to just go and, you know, eat dirt.
Yeah.
So I mean, wash your vegetables. Right.
Just rinse them.
Give them a good rinse.
Give them good. Okay. Let's see. One more question. Can you discuss how testing is able to determine if the gut is in dysbiosis and unable to process certain amino acids? And speak to a little bit of that research there.
So different molecules that you test mean different things, right? So for example, we test so there's 3 different molecules that are called indole blank. So indole propionic acid, indole lactic acid, indole acetic acid. And each one of these things is actually produced by certain bacteria in the gut. So some of the more invasive bacteria produce indole acetic acid. So, you know, it just happens to be that some of the ones you just don't want make that thing. So if you test positive for that and have higher levels of that, then what that tells us is, okay, it means you have a dysbiosis, meaning that you have perhaps too many of those invasives. You know, if you have low levels of indole propionic acid, that means that you have low levels of the certain bacteria that produce that. That's a very important antioxidant, super important in a positive way. So if it's low, it means that those bacteria are suppressed, meaning there's probably not as many of them. So again, you probably have a dysbiosis and that you have more of the ones that you don't need or you don't want as many of. Indole lactic acid is interesting because it's actually a precursor of indole propionic acid. So the bacteria that take in indole lactic acid and then convert that into indole propionic acid. So if your indole lactic acid is low, that means you don't have typically enough of the precursor. Often indole lactic acid is low when indole propionic acid is low, because if you don't have enough of the precursor, then the bacteria aren't taking in enough of that to produce IPA or indole propionic acid. So that tells us, okay, you probably need to add more fermented foods into your diet in order to, you know, to get enough indole lactic acid to allow for the bacteria to convert it into indole propionic acid. So just an example of 3 things, but depending on which ones are high and which ones are low, it tells a very specific story about what you need to do to intervene. Do you need to just take a probiotic and, you know, get rid of your invasive bacteria? Maybe. Do you need to put more fermented food into your diet in order to feed the bacteria that need to, you know, flourish to prevent the dysbiosis? Or do you need to eat foods that have indole propionic acid? I mean, again, it's all just very dependent on the situation. Then if you test low for these proteins, right? So you're low on tryptophan, low on tyrosine, and you have the gut dysbiosis, then typically what will happen is the team will start with the gut dysbiosis problem, because it could be that the gut dysbiosis is actually preventing you from absorbing and breaking down your nutrients. We're not going to start just with nutrients, because shoving more food into the system isn't going to solve the fact that you're not breaking it down and absorbing it. But if your bacteria are fine and it's just a protein issue, then we would say, oh, okay, you know, it could just be a problem that's solved with increasing protein in your diet. Or, we look at some of the inflammation markers too. If the inflammation markers are high, we try to decrease the inflammatory response. So again, each of the markers means something different in its own context, but also in the context of all the others. So it tells a really nice kind of story for where to start, if that makes sense.
Yeah. Oh yeah. Lots of chain reactions happening.
Yes. Well, they're all interconnected. Everything is interconnected in the body.
It is. Yeah, that's crazy. But Erika, thank you so much. I've now kept you 3 more minutes longer than we've allotted you for. No, but we appreciate your time as always. Thank you so much. Team, make sure that you jump on the top of the hour. Matt Driller, he's going to cover sleep and recovery. So make sure you catch that one. Should be exciting. But thank you so much, Erika. We really appreciate you.
No worries. Thank you so much.